Hello, my name is Robert Smith and I'm with New River Community College, and today we are looking at the effect of acid on the solubility of a substance. Some substances will dissolve more readily in acids and some substances will not. So we're going to take a look at that and we'll determine for each of these species whether they are more soluble in acid or if there are no change in their solubility between acid and water. So for our first species, we have iron 2 sulfide, which the first thing you'll want to do in any of these cases is write out the dissolution reaction, the equilibrium reaction for its solubility. So it breaks down to Fe2 plus S2 minus. And the second thing we'll want to do is consider the anion. That's the product of that's the part of this salt. So we're considering sulfide. Sulfide is going to be the conjugate base of some acid. And to do that, we just simply look at S2 minus plus H plus, and that's going to give us HS minus. HS minus is that is a weak acid, and because it is a weak acid, and the conjugate base being S2 minus, we can apply Le Chatelier's principle, and this is because it's a weak acid. So from Le Chatelier's principle, we can determine that if this iron 2 sulfide were to dissolve in water, or in acid rather than water, that these free protons would react with the sulfide ions and produce HS minus. But that means that you're taking away some of the sulfide ions from the top equation, this equation up here. So by removing some of the sulfide ions, if you recall, Le Chatelier's principle states that the reaction will proceed toward the side that has some of its species removed in order to reach a new equilibrium. So that means that this reaction will proceed to the right, which means that it is more soluble in acid than in water. Silver bromide, you can do the same process. So for AgBr, we go in both directions here, and we have Ag plus Br minus. Now, bromide plus H plus gives us HBr, which is a strong acid. So this one was a weak acid, and this one is a strong acid. Because this is a strong acid, it doesn't want to go in the direction that I wrote it in. It only wants to go toward Br minus. So that doesn't really qualify, and that means that if you were to try to dissolve silver bromide in acid versus water, you would get the same result. The water would dissolve just as well as the acid would. Finally, zinc sulfate is more akin to the first one. You have Zn2 plus, so you have Zn, got ahead of myself there. So you have ZnSO4, and it's in equilibrium with Zn2 plus SO4 2 minus. SO4 2 minus plus H plus would give us HSO4 to SO4 minus, which is a weak acid. So that allows us to say that, again, Le Chatelier's principle would apply, because recall, weak acids are in equilibrium. They do not have a one direction reaction, so you can just as easily say it's like that. And so the reaction would proceed to the right again. So zinc sulfate, just as with iron 2 sulfide, are both more susceptible to dissolution and solubility in an acid solution. Conversely, silver bromide is not susceptible to any further solubility in acid as opposed to water.